Alright, Neo-Gothic architecture. It may sound like a daunting challenge, but once you start breaking down the different elements and patterns that are part of this style, you can start planning your approach. You know you're gonna have to deal with a lot of columns, fancy windows, triangular shapes, ornaments, a lot of elements like that are repeated on the model. At the granular level, it's not that complicated. The buttress is a key feature of the Gothic style too, so that's a type of thing we could have a look at some point, but I want to focus for now on a tower like this. So let's break down this bad boy. It might sound complicated, but really it's not that big of a deal. So let's see. The beginning, we are starting with an octagon that we are extruding. Got my nodes AL top bottom, which basically just in this case create a group for the bottom. Knives up is a node I love using as it allows to slice the model in a certain direction. For that, you need to specify an origin, a distance from origin, and a direction. In that case, I'm using the point number 9 to move the origin to its height. So if I start adjusting the distance, it's going to move my edge loop away or closer to point 9. That's pretty sweet. If I want to define point 1 as the origin, I will just need to replace 9 by 1 in my point expression, and now the distance is based from this particular point. In my case, I was happy with my original settings and my point number 1 as the origin. Yep. And in addition, the knife sub also offer to export some groups, the groups that are below the slice and above it. So in that case, it allowed me to extract some geometry like this. That kind of helped making the work easier down the line. And also I like to align a grid on the center of a shape that I'm extracting. So in that case, it's just entering this grid and I will reuse it later to define the position of something else. Moving on, we have this window setup that I want to show you, and it's actually very simple. We are starting from this shape and we need to end up with that. So what we are doing here is closing the geometry with polyfill, then extracting the bottom face and using this AGA AL middle point to actually extract the middle point of each segment. So how it works is actually very simple. Basically creating a group at this level, doing a resample to add a point in the middle with this feature right here. We could add 3, 4, whatever, but in that case, I just need 2 segments to define the middle, and then retransferring the base group. Here we go. So this group actually end up in here, and we can then blast the base group to just keep the middle points. And those points will define the position of our windows. So as you can see here, we have orientation along curve to make sure the orientation of those will be in good place. And yeah, that's the result of this. So this is some shape that we'll use for Boolean. Had fun making this little tool to control the shape of the windows, would make things much easier down the line. So how it works is just a box with some segments and scaling this guy in Z, so to make it very thin. Then I'm using a point VOP to lerp between those 2 inputs, the first one and the second one, basically mixing the position. And I'm using the relative bounding box y-axis to use it as a mask for blending those 2 inputs. That's very simple stuff. Then extruding the bottom face just to have a longer window, and that's pretty much it. Then I'm exposing all the settings in there and we are all good. Can tweak this shape if you want to get something pretty funky. Why not? Let's try that. So my window is much bigger than before, I guess. Yeah, let's see. And I'm looking backwards. Yeah, that would be the idea here. Yeah, here you go. You can have a completely different window in a sec. I was happy with that though, yeah. Moving on, I'm doing some more slicing and I guess adding more windows in here, yep. And yeah, that's a pretty good base, but how do you get that more detailed now? So the trick here is to extract the edges of the window. And you can use dissolve as a way to blast edges, because blast node doesn't blast edges. And I'm using the Boolean group AB seams. This way I'm extracting a curve and I'm doing a sweep operation with that. For a sweep you need a profile, so I draw this profile shape that I'm reusing all over the building. So it's manually basically pushing polygons in Blender to get these shapes. And one thing I did is creating this little HDA simple border. It's just a few nodes in there, a group to group unshared edges. Yep, so it's a group called border and it's an edge group, and I'm dissolving everything but this group. I'm reusing this setup quite a lot, that's why I created a HDA out of it. And yeah, then you put that into your sweep. In that case, I'm calling this profile with an object merge. And yeah, you can play with the sweep to adjust the scale of the profile. You can rotate it too if you want. So that would be the roll settings here. Yeah, that's kind of hypnotizing. And anyway, moving on, just this way we can create all those borders. That looks pretty detailed. And let's see, yeah, some more of these. And yeah, in the end, it really helps selling the complex look of Gothic architecture. Yeah, there's a few more stuff that we can break down. We have this guy right here, which is the kind of triangular shape. So I'm just copying this with the same way than the windows, projecting that on a plane just to make sure that it fits with the tower. Doing some Boolean to merge those guys together, actually. That's the original geometry that I'm using, and I'm doing a Boolean in union to merge those properly. And now when I'm using a Boolean in a seam mode, it's basically slicing everything to extract a curve. So this is basically just a grid that I'm using to intersect with the geometry that we just created. So this guy, and as soon as it intersects, it's gonna extract a shape, a slice, if you want, of this model. You just need to set the Boolean to seam. Yeah, and it will return this kind of result. That's pretty neat. We can use that if we want. I use a sweep. In that case, I'm using a match size to fit it at the bottom of my shape. So just set the justify Y to minimum, and here you go. So in that case, I'm basically fitting it at the bottom of the windows so that I can then sweep this guy. And when I merge everything, we have this nice decoration in here. So it really helps also on adding complexity to the model. All right, Gothic style, it's pretty much like the cones of Downshire. It's all about the cones. It all begins with an octagon on which I'm copying some boxes. So that's the base shape, copying the box, isolating the top face so that I can start working on this section. So since those features are repeated all over the building, I created some HDAs to make the setup a bit easier. So this particular one, the triangle top, just generate a triangle at the base of every edges of a polygon. So in that case, it's just a quad. But yeah, it's basically fitting some triangles in there. So how it works, very much like the rest, I'm using AL middle point to extract the middle point of every edges, like so. And I'm transferring the normals again, just like what we did in the past with the windows and all that stuff. So this is transferred on the normal, as you can see if I display, yep, those. The model should point toward the proper direction now. So that's actually super simple, but at the same time contribute a lot to the Gothic effect in the model. If I disable the normal, well, an orientation is messed up, of course. The shape I'm copying is just this simple box with a taper on the top. So really nothing complicated here. All right, that was AL triangle top. Moving on, we got this setup right there. I won't drag too long on this one, since it's very much what we saw before with the sweep node, and expose some parameters. This one, well, it's a little bit more interesting, but nothing groundbreaking either. It's still very simple shapes, and you just control whatever features you need in there. If you need more taper, more elements, change the scale of those details, this type of stuff. So these kind of features are repeated a lot over the building, so really wanted some kind of solid setup as an HDA. Let's see what we have. Just a poly extrude to get the height of the cones. I don't know what this blast is here for. It's probably a mistake. Let's kick that. Anyway, poly bevel to kind of get something more or less round in the edges. Adding kind of a little detail there, just extracting the center of each face and copying this element on it. So like fairly low res kind of detail, but that does a job in the distance. Then again, you don't necessarily want 1 million polygon repeated just for something like that, you know. That's still need to make sense for what we see and the distance we see it. Then we have those ornaments right there that are set on the edges of the cone. First, I'm modeling real quick this stuff with a box and smoothing it just on one side, extruding the base, and yeah, that does kind of give us something to start with. I need to extract those vertical edges. To do so, I'm basically starting by creating a group of edges. So that would be, let's say, a group base, and on this group base, I'm subtracting the unshared edges. And this way I'm left with the vertical ones. So that's pretty neat. Then once we have like those wires, you can dissolve everything but the vertical lines, the group that we just created. Then you can basically carve those lines if you need to get the detail started or ending a bit earlier. And the resample, well, here is defining the amount of repetition you want on those curves. Okay, this node should be useless. I'm not sure why it's there, but yeah, the normal in this case is transferred from this specific geometry here. Yeah, let's decrease the normal size to kind of see a bit better. So yeah, I'm basically taking these normals, transferring those to the curve so that all the detail element will point toward this direction. So as soon as do the copy to point, everything should be in the proper direction. Yep, so I'm happy kind of with that. It's not perfect, there's some like kind of weird intersection, but yeah, kind of does the job. Then merging another layer of triangle thingy that are supposed to be on top of the windows. Yep, so that's kind of the general idea. Let's see, there's one more thing we haven't talked about yet, which is the very top section of this guy. Then again, it's always the same setup where you start with an octagon, extracting the middle point, transferring normal. So all those procedural setups is actually very easy. It's all about controlling the placement of things and their orientation with normals. Yeah, those ornament detail and stuff were already pre-modeled, so I didn't have to worry about doing that procedurally. There are still some stuff that makes sense to make in a procedural way, such as the placement. Let's say this guy, I'm just like copying to point and orienting properly to get the proper placement. Just in between those triangles, kind of help transitioning the whole thing and making it more natural, I guess. So yeah, what do we got here now? I think that's pretty much it for this part. Then if you've been working in a non-destructive way, such as in this case, if you're starting to change one feature, all the rest should follow properly. So that's one of the benefits of working procedurally. You can always adjust proportions and things like that. If, let's say, you need to extrude a bit more this area in the middle, well, everything still conserves this proper scale, orientation. So it kind of make things much more fun to adjust and iterate if needed. So looking at the rest of the tower, there are some features such as the placement of the columns that could be interesting to break down. If we look at the base, it's starting with this and turning into something like that. For organization's sake, I exported the packed primitive to the second output of this subnetwork. My idea being to keep the instanced model all together, and the rest, which is not an instance, are basically on their own branch. But yeah, if you really want to combine them for, let's say, visualization sake or for organization sake, you could also pack this branch and yeah, add it with the other one. I guess what's the worst case that can happen? Well, if you make something packed instance with something that is not, that can cause some issue down the line, some instability with Houdini, experience some crashing, things like that. So yeah, you want to be careful. Anyway, moving on, we have here some base polygons and just doing some extrusion, some inset, and it's all about dealing with group names and calling these groups within over poly extrude or other kind of stuff like that to manipulate the polygons. And yeah, that's how it end up looking like a messed up wedding cake. Yeah, but thanks to the groupings, you can always blast everything but a specific group, like in this case, and I'm using bounding box to define some region that's gonna define where I want the column to stop, start, and in here, this box will define the height of the columns and where they start, where they end, this kind of thing. Created this this HDA to just bring data like height as a detail attribute. It can also measure, well, different axes, but in this case, it's the y-axis. So it will just return its height of 0.13 in this case. So we're gonna see in a bit what does that mean. So in here, I'm working mostly on the middle section that transition with the other level. So we have this area and doing some extrude, creating these window holes and things. Like you can use an inset. It's always a nice way to add some kind of Gothic features and re-extrude it afterwards. So yeah, little bevel in this case. And yeah, you get something pretty nice. All right, so this area is all good. Now we just need some columns. As I was talking about, we have this area that contains the information where the columns should be, the height and that thing. So we can feed this information into the model of a column and then basically place those columns at the right place. So as you can see, I'm just extracting the kind of ground of the where should be my columns. So they should be here, and yeah. Let's see, copy to point. I got those columns. We're gonna see in a bit how that works. It's a very simple setup where basically I'm turning a column into a more detailed element like that. And the height is basically referenced in there. So I'm using a detail expression to grab the attribute from the measure height that we created earlier. And yeah, now as you can see, it's saying it's got a height of 0.13, just like what we had in here. So pretty handy. And yeah, this basically node adding some of these ornaments and stuff. All right, let's see how it looks now. Putting a merge together. And yeah, so that's fantastic. Our columns perfectly fit with the rest of the geometry, which is what we want. And it's procedural, so if you change something, the length would follow, etc. So yeah, when looking at the rest of the building, everything is pretty much the same techniques than we saw in this tutorial. We can of course break down some more stuff. Maybe in another tutorial we'll have a look at the buttress. Before ending this video, if there's one thing to remember here is get as many reference photos as possible to study and break down the patterns you see. Work in a way so you are able to easily and quickly apply a pattern to an entire section or a smaller portion of the building. It may sound like a lot of efforts developing those graphs, tools, or workflows, but believe me, down the line, it will really help you step up your game and iterate on creative decisions in no time. Just a reminder that you can get the tools I'm showing in this tutorial for a symbolic price on my Gumroad, so don't hesitate to check it out if you are interested. And that's pretty much it for today, guys.